Welcome to solverfy.
A quadratic function that has a root of 3 minus 2, I'm going to do my work down here. If it has a root of 3 minus 2i, then a factor would be x minus 3 minus 2i, but also its conjugate, 3 plus 2i, would be a 0. So this is x minus 3 plus 2i and x minus 3 minus 2i after distributing the negatives. And then we can multiply x squared minus 3x minus 2ix minus 3x plus 9 plus 6i, and then plus 2ix minus 6i minus 4i squared. So that's x squared minus 6x, positive and negative 2ix's cancel, positive and negative 6i cancels, 4i squared, I squared is negative 1, so that becomes a plus 4, so that would be plus 13. X squared minus 6x plus 13. A polynomial of odd degree can't have imaginary zeros only because the end behavior goes in opposite directions. Which means it must cross the x-axis, meaning there's a real zero. A possible function for what we see graphed, if we write it in factored form first, since it goes through negative 3, then x plus 3 is a factor. It goes through 1, 0, touches and turns around. That means x minus 1 is a factor multiplicity 2, and it goes through 4, so x minus 4 must be a factor. X minus 1 squared is x squared minus 2x plus 1. And then x plus 3 times x minus 4 is x squared minus 4x plus 3x is minus x minus 12. Multiply this out. We get x to the 4th minus x cubed minus 12x squared. Distribute the negative 2x, you get minus 2x cubed plus 2x squared plus 24x. And then distribute the 1, you get plus x squared minus x minus 12. Combine like terms, and we get x to the 4th minus x cubed, minus 3x cubed. Then we have minus 10 minus 9x squared plus 23x minus 12. But we know that if we substitute 0, we get negative 1. So we could scale this function by a 12. So we get 1/12 x to the 4th minus 1/4 x cubed minus 3/4 x squared plus 23/12 x minus 1.